Welcome to another deep dive. Today we're exploring something absolutely fundamental, though maybe a bit invisible sometimes, that really underpins so much of our digital world. It's all about navigating the API ecosystem, strategies for scalability and interoperability.
Yeah, it's key.
Exactly. I mean, APIs are these unseen connections powering, well, everything. From the apps on your phone to these huge enterprise cloud setups.
They really are the plumbing, but very sophisticated plumbing.
Right. So our goal for this deep dive, and this is custom tailored for you based on the sources you shared, is really to cut through the noise. We want to pull out the most important insights about API design, management, and, their strategic impact. We'll be focusing particularly on how these interfaces scale, how they handle growth gracefully, and how they manage to work together seamlessly, even when you've got completely different systems trying to talk. Think about a company, let's call them Innovate Corp. Maybe they're growing fast, wrestling with connecting, say, an old customer database with some cutting-edge AI tool and a brand new mobile app.
The classic challenge.
Totally. And our deep dive today is going to reveal how APIs provide the blueprint for Innovate Core's success, letting them scale up and integrate all those diverse bits of tech. Okay, let's unpack this fascinating world of APIs and see how they tackle these real-world problems.
And it really is a pivotal area.
Right.
Understanding APIs isn't just for developers anymore, not by a long shot. It's pretty vital for anyone navigating this digital landscape.
True.
Whether you're a technical manager leading teams, maybe a product owner thinking about new features, or frankly, just curious about how the digital world actually works together.
Yeah.
Getting APIs is becoming more and more crucial. Fundamentally, APIs, application programming interfaces, they're basically these meticulously defined rules, protocols that let different software applications communicate and swap data.
Like translators, or maybe contracts.
Contracts is a good way to put it, yeah. They act as these indispensable conduits, allowing separate systems to interact, to leverage each other's functions, without needing to understand all the complex internal stuff going on inside each other. And the compelling why now for diving into this. It really stems from this huge industry shift we're seeing. More and more organizations are rapidly embracing things like modular microservices and cloud-native architectures.
Right, everyone's talking about microservices.
Exactly. And this widespread adoption means that the ability to properly design, manage, and ensure the scalability and, crucially, the interoperability of APIs have become this deeply pressing strategic issue. It's not just about building individual services anymore. It's critically about how those services connect, how they interact, and how they perform together as one cohesive, distributed system.
Makes sense.
So in this deep dive, we'll definitely explore the current trends in API development. We'll get into the best practices that drive not just technical, but actual business scalability, and really focus on how fostering that interoperability, making things work together across different tech stacks, is the key to unlocking innovation, efficiency, and frankly, a real competitive edge.
That sets the stage perfectly. It really does feel like APIs have gone from being, obscure technical plumbing to basically the foundation of the whole digital economy. Like suddenly they're everywhere. How did we actually get here? What was that big shift?
That's a great observation, and it points directly to this profound architectural change in software development that really picked up speed over the last decade or so. The biggest catalyst, it has to be the undeniable shift towards microservices architectures.
Okay.
For a long, long time, software was typically built as these monolithic applications. Think one single, enormous, tightly coupled code base where everything, user logins, payments, whatever, was all jammed into one giant unit.
The monolith. I remember those days.
Right. And while they might seem simpler to deploy initially, these monoliths became incredibly difficult to scale, to update, to maintain as they get more complex. Any tiny change often meant recompiling, redeploying the entire application. Slow, risky, a huge bottleneck for actually getting things done quickly.
Yeah, agility killer.
Totally. So the move to microservices fundamentally changed that whole picture. Instead of one big application, you break it down into a collection of small, independently deployable services. Each service runs its own process, handles its own data, focuses on a specific business capability. User management, order processing, inventory. Think back to Innovate Core. Instead of one giant app, now they have separate services for customer accounts, their product catalog, order fulfillment.
Okay, so modular.
Exactly. And this shift happened mainly because companies desperately needed more agility, faster deployment cycles for different parts, and the flexibility to pick different technologies for different jobs. If Innovate Core's customer service really benefits from a specific NoSQL database for flexibility, but their billing system needs a rock-solid relational database for transactions, they could do that without impacting each other.
That flexibility sounds key.
It is. But here's the crucial part. Once you break apart that monolith, how do these separate independent services actually talk to each other? That's precisely where APIs became the critical glue. APIs define the exact contract for how these distributed services communicate effectively. They're the consistent interface between them. Without robust, well-defined APIs, a microservices setup would just descend into chaos. Services wouldn't know how to find each other or understand how to interact.
Right.
APIs also provide these crucial ways to handle the inherent challenges in microservices, like how do you manage data consistency across different services, or how do services find each other? APIs give you those clear, standard communication channels to solve those problems.
So APIs aren't just connectors, they actually enable this whole microservice approach, this more agile way of building software. And it sounds like some companies have really doubled down on this, not just using APIs inside, but making them a core business strategy. What does a successful API-driven company actually look like?
Absolutely. A successful API-driven company isn't just using APIs as a technical detail or an afterthought. For them, APIs are a fundamental business asset. They're strategically designed to unlock new products, build new partnerships, even create entirely new revenue streams. These companies get that opening up their services through APIs can totally transform their business model and extend their reach way beyond just their own apps.
Interesting. Can you give us a sense of the types of companies doing this well, maybe without naming names?
Sure. Think about the kinds of companies making that shift from just being a service provider to becoming a platform. Consider, say, a big financial institution that runs a global payment network. Their core job is handling secure, high-volume transactions.
Okay, like a payment processor.
Exactly. By offering really solid APIs, they let any e-commerce site, any mobile app, any point-of-sale system integrate their payment processing directly and securely. They essentially become the invisible backbone for countless other businesses. This expands their market share, their global footprint, all without needing to build every single customer-facing app themselves.
Right, they let others build on top of them.
Precisely. Or think about a major logistics company, shipping packages worldwide. They offer APIs that let businesses integrate real-time package tracking, shipping label creation, delivery scheduling right into their own systems, whether it's their internal planning software or their customer service portal.
I can see how that's powerful.
These companies used APIs to basically create new markets or seriously disrupt existing ones by making their core functions accessible, programmable for this huge audience of developers and other businesses. They went from just offering a service to building a platform others could innovate on. And that doesn't just fuel incredible third-party innovation, which often leads to uses and revenue they never even imagined it about. It also massively accelerates their own growth and influence. It builds this whole vibrant ecosystem around their services.
That makes total sense. It's about creating possibilities for everyone. And if you think about it from, the user side, this all connects directly to the experiences we have every day, right? How do these APIs, humming away behind the scenes, actually make things better for us, the end users, and keep us engaged?
That's a crucial link, yeah. Because ultimately, all this tech infrastructure exists to create a better, smoother experience for the person actually using the software. APIs are the silent conductors behind so much of the frictionless integration we just expect now. Forget just log in with social media for a second, which is still powered by APIs, of course. Think about something more complex, like maybe supply chain integration for a big retailer.
Okay.
When you order something online from a major site, you expect to see real-time shipping updates, right? Maybe even a map showing where your package is.
Yeah, definitely.
You also expect it to update your order history, trigger the warehouse to pick it, adjust the inventory count. This whole complex dance involves maybe the shipping carrier's API sharing location data, a customs API handling international docs, an inventory API updating stock, a customer service API sending you notifications, all happening seemingly effortlessly from your perspective. It's this symphony of internal and external APIs making a potentially messy global process feel intuitive and transparent.
Wow, when you put it like that.
Right. And this constant, often invisible data exchange leads to richer, more integrated, and just way more convenient user experiences. Instead of manually tracking a package on 3 different websites or jumping between apps to manage an order, you can often do complex things within one interface. This cuts down friction, saves time, and ultimately drives user engagement and, stickiness. People are more likely to keep using apps that feel convenient and integrated like that.
Yeah, you just get used to it working well.
Exactly. When apps feel connected and smart, it creates this sense of effortlessness that builds loyalty and satisfaction. And for businesses like Innovate Corp, that directly translates into keeping customers happy and boosting their brand value.
It's truly amazing how much complex coordination is happening under the hood for that smooth experience. Okay, so we've talked about why APIs are so crucial and how they became foundational. Now let's shift gears a bit to the how of making them work reliably, because if they're so central, they absolutely cannot break down, especially when demand suddenly goes through the roof.
Right.
So if APIs are this critical glue connecting everything and powering businesses, how do we make sure they don't just buckle when, I don't know, a million people try to use them at once? How do you design an API to handle that kind of massive, maybe unpredictable growth and scale smoothly?
That's the million-dollar question, isn't it, for any growing digital product? And it really comes down to being intentional about designing for future growth right from the start. One of the first big decisions you make in API design, especially thinking about scalability, often revolves around the architectural style you pick. The two dominant players here right now are REST and GraphQL. And the choice between them really impacts how your API scales and how efficiently clients can talk to it.
Okay, REST and GraphQL. I hear those terms a lot.
You do. Let's start with REST, representational state transfer. It's been the go-to, the traditional style for web services for, well, over a decade. It builds on existing web standards. Its principles are pretty straightforward. It's stateless, meaning every request from a client have all the info the server needs. That simplifies server design and makes horizontal scaling easier. It's client-server, separating concerns. It's cacheable, so you can store responses to speed things up. And it uses a uniform interface standard HTTP methods like GET, POST, PUT, DELETE for interacting with resources.
Resources like users, products, that kind of thing.
Exactly. REST is great for those resource-oriented services. Its popularity comes from its simplicity, how it aligns with web standards, and it's pretty easy to grasp for many common situations. You just ask for a specific resource at a specific URL, and you get its representation back.
Sounds straightforward enough. So what about GraphQL? Why did that emerge?
Well, GraphQL came about partly because of challenges REST sometimes faced, especially with mobile apps and really complex data relationships. Facebook actually developed it back in 2012 to solve their own issues with fetching data efficiently. The core idea behind GraphQL is that the client specifies exactly what data it needs. Instead of having multiple REST endpoints for different resources, GraphQL usually has just one endpoint. Clients send queries using this powerful, strongly typed query language.
So the client asks for specific fields.
Precisely. It lets clients request only the fields they need, even from related things, all in a single request. This is a huge win for complex data graphs, where with REST, you might end up overfetching, getting way more data than you need, wasting bandwidth or underfetching, having to make multiple round trips to get all the related bits, increasing latency.
Ah, I see. Especially painful on mobile networks.
Absolutely. For mobile apps where network conditions can be flaky and latency matters a lot, cutting down the number of requests and the data transferred is a massive performance boost.
Okay, so when do you choose one over the other? Is there a clear winner?
No, there's definitely no one-size-fits-all here.
Yeah.
It really depends. If your project is mostly about straightforward resource manipulation, or maybe you're building a public API where things like cacheability and simplicity are really important,
Yeah.
REST is often a very solid, familiar choice. It's got huge support.
Right.
But if you've got complex data relationships, if your client needs change frequently, like a mobile app showing different data based on screen size or user role, or if you need super efficient tailored data fetching, especially for mobile, GraphQL offers some big advantages by giving the client more control. You also have to think about your existing setup, your team's experience, how easy each is to maintain long-term, especially around caching. Both can be designed to scale, for sure, but they do it differently. The right choice really hinges on your specific needs and context. Maybe Innovate Core uses REST for their core product catalog, but GraphQL for their flexible new mobile app front end.
That's a very clear breakdown, thanks. So you pick your style. But APIs aren't static, are they? They evolve. New features get added, old ones might change or disappear. How do you manage that evolution without breaking all the existing apps that depend on your API? That sounds terrifying.
It absolutely is terrifying if you don't handle it carefully. And that's exactly why API versioning strategies aren't just a technical detail. They're critical for managing your API's lifecycle and your relationship with everyone using it.
Yeah.
The whole point of versioning is to let your API evolve, add features, maybe make breaking changes, without immediately forcing every single client application to update. That would cause chaos and frustration.
Okay, so how do you do it? What are the options?
There are several common ways, each with pros and cons. The first, and maybe the simplest to grasp initially, is URI versioning. You stick the version number right in the URL, the path, like AP would users or a P2 products.
Simple enough. Seems obvious.
It is simple and very discoverable, yeah. The version's right there. The downside, some call it URI pollution. Your URLs get longer, and you end up with multiple paths for basically the same resource as it changes over time. Can get messy to manage, especially with lots of versions.
Okay, what else?
Another popular one is header versioning. Here, the client sends a specific custom header, maybe something like accept.dead, application vnd.myappy.v1 plus JSON, telling the server which version they want. The server looks at the header and processes accordingly.
Ah, so the URL stays clean.
Exactly. It keeps your URIs cleaner, more focused on the resource itself, because the versioning is in the request metadata. The drawback is it's less discoverable just by looking at the URL, and it might need a bit more setup for clients or tools that aren't used to custom headers.
Right.
And then there's query parameter versioning. You pass the version as a parameter in the query string, like apusers.version1. This is pretty easy to implement, flexible for clients to switch versions, but some argue it's less semantically clear. Query parameters are often for filtering or pagination, so adding versioning there might muddy the waters a bit.
Okay, so trade-offs everywhere.
Trade-offs everywhere. Simplicity versus cleanliness, discoverability versus semantics, maintainability. And crucially, how easy is it for your clients to adopt and migrate? No matter which method you pick, the absolute key is clear, proactive communication with your API consumers. Tell them about deprecation policies when old versions will be turned off, provide clear upgrade paths. Good documentation around versioning is essential to minimize friction and let you keep improving your service without breaking things for Innovate Core's partners or internal teams.
That's a lot to juggle just for versioning. Beyond picking the right architecture and handling versions, what are some common mistakes or pitfalls API designers fall into? Because I imagine it's easy to mess up in ways that hurt scalability or just make life miserable for developers trying to use the API.
Oh, absolutely. You're right. There are several frequent mistakes that can really cripple an API's scalability, maintainability, and, yeah, the developer experience, which is so important. One common pitfall, and it can sneak up on you, is inconsistency.
In what way?
In everything. Inconsistent naming conventions, sometimes user-ed, sometimes user-ed, inconsistent response formats, maybe JSON here, XML there, or different structures for similar data. Inconsistent error handling different codes or messages for similar problems across different parts of the API. Imagine the hidden cost for Innovate Core's developers spending hours just figuring out the naming or error format for every single new endpoint. It's a productivity killer.
Ugh, yeah, that sounds frustrating.
It really is. Having a unified API-style guide is so critical to avoid this chaos and make the API predictable, easy to learn. Another big one is overfetching or underfetching data.
We touched on that with REST versus GraphQL.
Exactly. With traditional REST, clients often get either way too much data they don't need, overfetching, which wastes bandwidth and slows things down, or too little data, underfetching, forcing them to make multiple extra requests to stitch everything together, adding latency. This is where GraphQL shines, letting clients ask for exactly what they need. For REST APIs, you need to think about building in flexibility, maybe allowing field selection or ways to request related resources efficiently.
Makes sense. What else?
Poor error handling. This is a huge source of developer frustration. Getting back vague, generic, or just unhelpful error messages leaves developers totally in the dark.
Like just error occurred.
Exactly. Useless. Best practice is clear, standardized error responses. Include a specific error code, a human-readable message explaining what went wrong, and ideally, a link to documentation for more details. That empowers developers to figure out and fix problems quickly. Imagine debugging Innovate Core's app and just getting error. It's maddening. Then there is the critical but sometimes overlooked mistake of ignoring authentication and authorization until it's too late. Building APIs without solid security from day one is like building a house and forgetting the locks. Security has to be part of the design, not bolted on later. Proper API keys, OAuth 2.0, making sure only the right users and apps can access the right data.
Yeah, security can't be an afterthought.
Ever. And finally, a really pervasive issue that just kills adoption is lack of good documentation. An API without clear, up-to-date documentation is practically unusable. If developers can't easily figure out what an endpoint does, what it expects, what it returns, how to authenticate, they'll just give up and go elsewhere.
Documentation is key.
It's not just reference, it's the main onboarding tool. A developer trying to integrate with Innovate Core's new Analytics API will get incredibly frustrated and look for alternatives if the docs are bad. All these seemingly small issues add up and make an API a nightmare to work with, totally undermining the investment in building it.
Wow, those pitfalls really drive home that API design is so much more than just functionality. It's about the whole developer experience and long-term health. Okay, so we've designed them well, hopefully avoiding those traps, aiming for scalability. But the digital world is this huge, messy place with tons of different systems and technologies. We talked about the digital Babel Tower. How do we actually get our well-designed APIs to speak the same language, to work seamlessly across this incredibly diverse landscape?
That's exactly where interoperability becomes absolutely critical. Without it, the whole promise of APIs as connectors kind of falls apart, and businesses like Innovate Core would really struggle to weave together all their different systems. The practical impact is huge. Without good interoperability, connecting things becomes expensive, slow, error-prone. It just kills efficiency and innovation. This is why the importance of standards is just massive. Standards are crucial because they give everyone a common language, a common structure for describing APIs. They cut down ambiguity, and critically, they enable automation. They make sure different systems can understand each other's vocabulary and grammar, like having a universally agreed-upon blueprint.
Okay, so what kind of standards are we talking about?
For RESTful APIs, the Open API specification, which used to be called Swagger, is a huge one. It's a language-agnostic way to describe your API interface. Doesn't matter what language the API is built in, Open API lets you precisely describe everything. Your endpoints, the operations they support, input-output parameters, how authentication works, all in a machine-readable format.
Machine-readable? So tools can use it.
Exactly. That enables incredibly powerful automation. You can automatically generate interactive API documentation that's always current. You can generate client code in different languages directly from the spec. You can even generate server stubs to get back-end development started faster. This massively helps developer onboarding. They get an immediate executable contract. And it improves API discovery because tools can just parse the spec and know exactly what your API does. It's like handing out a universally understood interactive blueprint.
That sounds incredibly useful. What about GraphQL? Does it have something similar?
GraphQL has its schema definition language, SDL, built right in. This inherently promotes strong typing and a clear, well-defined schema. So GraphQL kind of provides this precise, self-documenting contract between the client and server right from the start. Because the schema strictly defines all the data types, the relationships, the available operations, it really helps interoperability. Clients know exactly what they can ask for and what they'll get back. Less guesswork, fewer errors during integration, and it enables really powerful client-side tools too.
So adopting these standards makes integration smoother.
Drastically smoother. When both the API provider and the consumer agree on a standard, they don't waste time trying to figure out each other's unique quirks. It speeds up development, lowers the barrier to adoption, and lets Innovate Corp integrate new partners or internal systems much, much faster.
Okay, so standards define the contract. But how do you actually check that two systems are following the contract and can really talk to each other? Is it just hope, or are there tools and ways to test this?
Oh, definitely not just hope. Simply designing for interoperability isn't enough. You have to rigorously validate it through ongoing testing. This is where various tools for testing and validating interoperability are essential. And we're talking beyond just basic unit tests here.
Well, what kind of testing?
Well, one really critical type is contract testing. This specifically ensures that both the client and the server are sticking to that agreed-upon API contract, the Open API spec or GraphQL schema. If the server changes something that breaks the contract, or a client starts expecting something the server no longer provides, contract tests catch it early before it causes problems in production.
Okay. That makes sense.
Then you have functional testing, which is more about verifying that the API endpoints actually behave as expected. Do they return the right data? Do they handle edge cases correctly? Performance testing is also crucial. How does the API hold up under load? What are the response times, throughput, error rates when lots of users hit it, like during a holiday sale for Innovate Corp?
Right. Got to make sure it doesn't fall over.
Exactly. And of course, security testing is non-negotiable. Finding vulnerabilities, injection flaws, bad authentication, insecure configurations before attackers do.
So what kinds of tools help with this?
There are categories of tools. Specialized API testing frameworks let you write automated tests for your endpoints. Mocking tools are incredibly valuable too. They let you simulate API responses from services that aren't ready yet or are external. This means Innovate Core's mobile team can build against the new AI service even before it's fully deployed, enabling parallel work.
Oh, that's smart.
Yeah. And finally, integrating all these tests into continuous deployment, CI/CD pipelines, is key. Every time code changes, automated tests run, catching interoperability problems right away when they're cheap to fix, not weeks later during integration testing.
It sounds like a lot of planning and foresight is needed. But even with the best standards in testing, the real world always throws curveballs, right? Can you give us some concrete examples of where interoperability gets really tricky and how companies usually tackle those challenges?
Yes, the real world definitely presents some tough hurdles. One of the most persistent challenges is integrating with legacy systems. Many companies, maybe like InnovateCore, have old monolithic applications built decades ago, maybe using proprietary protocols or outdated tech.
Yeah, the old mainframe in the corner.
Exactly. Getting those systems to talk to modern REST or GraphQL APIs can be incredibly hard because everything is different data formats, communication styles, security. Often the solution involves building a sophisticated middleware layer or an adapter that basically translates between the old and new worlds. It acts like a bridge, transforming data and protocols.
Okay, a translator layer.
Pretty much. Another common headache is data format mismatches. Even if everyone's using JSON, systems might represent things differently. Dates could be MMD here, a Unix timestamp there. Currency might be integer cents in one place, a floating point number in another. Hello, rounding errors.
Subtle bugs.
The worst kind. You usually overcome this with really careful data mapping, maybe transformation logic in the API gateway or middleware, and just crystal clear documentation about expected formats. Authentication and authorization discrepancies are also big ones. Trying to bridge different security models, maybe simple API keys here, complex oath there, custom token somewhere else needs careful design. Often the API gateway plays a central role here, maybe converting credentials or enforcing a consistent policy at the edge, hiding the internal messiness from the client.
Okay, centralizing security helps.
Definitely. And finally, version drift is this constant threat. This happens when clients and servers get out of sync on API versions, leading to weird behavior. A client expecting V1 gets a V2 response that's missing a field it needs, and boom, it crashes.
Right, back to versioning.
Exactly. Which is why strict versioning policies, clear communication, and proactive deprecation strategies are vital. You need to guide clients through upgrade smoothly. In all these tricky situations, it usually comes down to a mix of careful design, smart use of middleware or gateways, and sticking rigorously to those standards we talked about to minimize the pain for companies like InnovateCorp.
That's incredibly insightful. Okay, so designing robust APIs is one piece, making sure they talk to each other is another huge piece. But then actually managing them all at scale, keeping them secure, tracking performance, that sounds like a whole different level of complexity, a monumental task almost.
Exactly. I mean, building the APIs is hard enough, but then managing dozens, maybe hundreds of them at scale, keeping them secure, monitoring performance, handling who gets access, making sure they actually meet business needs. It really does sound like a whole different beast. You couldn't possibly do all that manually, right? Especially for a company like InnovateCorp with lots of services popping up. This is where API management tools come in, I assume. Tell us about API management. Why is it so essential for long-term success? You've absolutely hit on a crucial point. As organizations scale up their API usage, relying on them for core functions, internal integrations, external partnerships, trying to manage it all manually becomes completely unsustainable. It's risky, inefficient, just chaotic. This is where API management platforms become indispensable. Think of an API management platform as a centralized control system for your entire API ecosystem. It helps you design, publish, document, analyze, and secure your APIs throughout their whole lifecycle, from the first idea to eventually shutting them down.
Like an air traffic control tower for APIs.
That's a great analogy. Yeah. It provides that overarching governance and visibility that would otherwise be impossible to achieve.
Okay, so what do these platforms typically do? Any examples?
Sure. Let's look at a couple of well-known ones. Apigee, which is part of Google Cloud now, is a really powerful enterprise-grade platform. It does a lot. It acts as a proxy, sitting in front of your backend services, handling requests. But critically, it provides advanced features for security enforcing API keys, OAuth, threat protection. It handles rate limiting, controlling traffic flow. And it gives you deep analytics and monitoring who's using your APIs, how are they performing, are there any problems. Apogee also has strong developer portal features, making it easy for external developers to find your APIs, learn about them, and sign up themselves. It's great for large organizations, maybe a scaled-up Innovate Corp, managing a big, complex portfolio of APIs.
Okay, enterprise grade. What about other options?
Then you have things like AWS API Gateway, which is a fully managed service within Amazon Web Services. It's designed to help developers easily create, publish, maintain, monitor, and secure APIs at pretty much any scale. Its big strength is its tight integration with the rest of the AWS cloud.
So it works well if you're already on AWS.
Exactly. You can easily connect your APIs to serverless functions, like Lambda, or other AWS compute storage databases. Both Apogee and AWS API Gateway and others like them share common vital features. They offer lifecycle management, a central place for security policies, analytics dashboards, developer portals, and often even features for API monetization.
That's a good overview. You mentioned monetization again. That's fascinating. So APIs can actually be direct revenue generators, not just efficiency tools. How does that work in practice?
Yes, absolutely. APIs can definitely become a significant direct revenue stream. It's a key part of what people call the API economy. There are several common ways businesses monetize their APIs, depending on their model.
Okay, like what?
Well, one popular model is tiered access. You offer different service levels based on subscription tiers. Maybe a free tier with limited calls per month, a basic tier with more calls and features for a small fee, and a premium tier with high limits, advanced stuff, maybe dedicated support for a higher price. This lets you cater to different users, from hobbyists trying things out to big enterprises needing serious volume.
Right, like software subscriptions.
Pretty much. Another way is pay-per-use. Customers get charged based on exactly how much they use the API, maybe per call, per gigabyte of data transferred, or even based on the complexity of the request. Think of it like a utility bill for your API usage. Good for services where usage varies a lot.
Okay, pay as you go.
Then you have freemium models. These combine free and paid. Basic access is free, which encourages adoption unless people try before they buy. But advanced features, higher limits, maybe premium data that requires payment, great for getting users in the door.
Makes sense. What else?
Beyond just usage, you can monetize data as a service. If your company has valuable data sets, maybe real-time market data, specialized geographic info, niche analytics, you can package access to that data via APIs and sell it. Turns your data into a product. And finally, APIs are crucial for building partner ecosystems. You provide specific APIs to partners, enabling them to build new apps, integrate your services, or exchange data in ways that benefit both sides. You might charge partners for this access, or the benefit might be indirect expanded reach, brand exposure, new opportunities created through those partnerships. For InnovateCore, monetizing APIs could drive new growth, spark innovation from others, and really strengthen their market position.
That's brilliant, turning tech into a business opportunity. But flip side, when you add all these management layers, security checks, rate limits, analytics, does it sometimes slow things down or create friction for the developers actually trying to use the APIs? How do you balance that essential developer experience DX with the necessary management overhead?
That is a classic tension, absolutely. And finding the right balance is critical for API success long term. API management gives you vital control, governance, insights. But if it's implemented badly, yeah, it can definitely create friction for developers, making them frustrated instead of productive.
So how do you get DX right?
Developer experience, DX, is all about making it as easy and ideally pleasant as possible for developers to find, understand, integrate with, and get value from your APIs. This means crystal clear, comprehensive, always up-to-date documentation. It means intuitive, well-designed developer portals where they can easily sign up, get keys, test endpoints, find code examples, see their usage stats. Onboarding should be smooth, self-service if possible, minimize manual steps. And crucially, the API design itself needs to be consistent, predictable, following conventions, so developers aren't constantly relearning things. When DX is good, developers are productive, they adopt your APIs faster, they become advocates. Imagine an Innovate Core dev finding everything they need in minutes versus one digging through old wikis and filing support tickets. The difference in output and morale is huge. Affects time to market directly.
Right. And the management overhead side?
The management overhead is the operational work involved in managing security policies, routing traffic, collecting analytics, handling versioning across potentially hundreds of APIs. Without good tools, this is a massive drain. Manually setting rate limits everywhere, trying to aggregate logs, onboarding every developer by hand, it just doesn't scale.
So the tools help automate that, right?
Exactly. Effective API management platforms aim to strike that balance. They automate many of the routine, repetitive governance and operations tasks, freeing up developer time. They provide powerful centralized tools for enforcing security, managing access, getting insights, but they do it in a way that enables developers, not hinders them. The goal is to provide the necessary guardrails and visibility for management, while making sure developers have the autonomy and clear paths they need to innovate quickly. The platform should feel like an enabler, a helper, not a bureaucratic bottleneck, letting developers focus on building cool stuff, not wrestling with infrastructure or red tape.
That makes perfect sense. So API management platforms give you the big picture control, but drilling down a bit, there's another component often mentioned that seems to do a lot of the real-time heavy lifting with traffic and security, the API gateway. What's its specific job? Is it part of API management or something different?
That's a really good clarifying question because, yeah, the terms can get a bit blurry sometimes. Think of an API gateway as a specific technical component. It's often a core runtime piece of an API management platform, but you can also deploy gateways standalone. Its main job is to act as a single entry point for all the requests coming from clients. It intercepts everything and routes those requests to the right backend service or microservice. Essentially, it's a specialized reverse proxy sitting between the outside world and your internal services, orchestrating the traffic flow.
Okay, so it's the front door.
Exactly. The front door, the traffic cop, maybe the security guard too. A lot of the heavy lifting you mentioned happens right there at the gateway. It's absolutely critical for making microservices work at scale.
So what kind of heavy lifting are we talking about? What does it actually do?
It does quite a few crucial things. First, request routing. It figures out where each incoming request needs to go based on the URL, maybe headers, other rules, and sends it to the correct internal service. Hides all that internal complexity from the client. Then, API composition or aggregation. This is really powerful. A client, like Innovate Core's mobile app, might need data from several microservices at once, user details from one, order history from another. The gateway can make those multiple internal calls and stitch the responses together into a single response for the client. Simplifies the client code a lot and cuts down on network back and forth.
Ah, that's clever. Saves the app from making tons of calls.
Precisely. It can also do protocol translation. Maybe your backends use different protocols, some REST, some gRPC, maybe even old SOP services. The gateway can translate between what the client sends and what the backend expects, letting everything work together. Crucially, authentication and authorization enforcement. This is where security checks get centralized. The gateway verifies API keys, checks OAuth tokens, makes sure the caller has permission before the request even hits your backend services. Protects them from bad actors.
So security happens right at the edge.
Right at the edge. It also handles rate limiting and throttling, enforcing those usage limits we talked about to prevent abuse or overloads, and caching. The gateway can store responses for frequently requested data. If the same request comes in again quickly, it serves it from its cache instead of bothering the backend. Huge performance win.
Faster responses, less load. Nice.
Yep. And finally, logging and monitoring. It's a natural choke point to collect detailed logs and metrics on all API traffic. Gives you invaluable insight into usage, performance, errors, all in one place. So while the API management platform might be the dashboard and control center, the gateway is often the engine actually enforcing policies at runtime. It simplifies things for clients, boosts security, improves performance, and gives you that critical visibility, really an indispensable piece of a scalable API setup.
That makes it much clearer. The gateway is doing a ton of work. Bouncer, concierge, traffic cop, like you said. You mentioned rate limiting and caching specifically. Can you dig a bit deeper into the techniques used there? Why are they so vital for performance and stability, especially when things get busy?
Absolutely. Rate limiting and caching aren't just nice-to-have features, they are fundamental techniques for building APIs that are genuinely scalable and resilient, that can handle those unpredictable spikes in traffic. Let's take rate limiting first. The why is pretty straightforward but critical. It prevents abuse, stops your back-end services from getting overwhelmed by a sudden flood of requests, whether it's a malicious denial of service attack or just a buggy client app gone wild, and it ensures fair usage so one greedy client doesn't hog all the resources.
So it protects the system.
Exactly. Now, there are common algorithms like fixed window, sliding window, token bucket to count requests over time, but the real challenge isn't just picking an algorithm, it's handling the tricky edge cases. How do you allow legitimate bursts of traffic without penalizing good users? How do you keep rate limit counters synchronized accurately if you have gateways running all over the world? Getting those nuances right is what makes a rate-limiting system truly robust enough to protect Innovate Core during, say, a massive product launch.
Right, the details matter. What about caching?
Okay, caching. The why here is also multifaceted. It drastically reduces latency for your users. Things feel faster. It significantly lowers the load on your backend systems. They don't have to work as hard. And it saves network bandwidth. If data doesn't change constantly, why fetch it from the source every single time?
Makes sense. Store copy closer.
Precisely. And there are different places you can cache. Client-side caching is when the app itself stores data locally, like Innovate Core's mobile app, remembering your profile picture. Proxy-side, or gateway caching, is when the API gateway stores common responses. Server-side caching is when the backend service caches data it gets from, say, a database. You use different strategies depending on how often the data changes and where the bottleneck is.
But what if the data does change? How do you avoid serving old, stale data from the cache?
That's the million-dollar caching question. Cache invalidation. How do you make sure the cache gets updated when the underlying data changes? And related to that is consistency, ensuring users see up-to-date information, especially if you have caches spread out geographically. If Innovate Core support updates a customer's address, how quickly does that change get reflected everywhere? These challenges are why thoughtful cache design, including smart invalidation strategies, is absolutely crucial for getting the performance benefits without sacrificing data accuracy.
That's a great explanation of how those seemingly simple ideas have deep implications. Okay, final point on gateways. Given they're the front door for all API traffic, how do you ensure the whole architecture is secure right from the start? What are the non-negotiable best practices for secure API architecture today?
Security cannot be an afterthought, period. It has to be baked into the API design from day one, and yes, the API gateway is a critical player in enforcing many of these best practices centrally. It's the foundation of trust for your whole API ecosystem. First and foremost, robust authentication and authorization. Authentication is about verifying who is making the request using things like API keys, the industry standard OAuth 2.0, or maybe JSON Web Tokens, JWTs. Authorization is about determining what that authenticated user or application is allowed to do.
Authn and Aussie.
Right. OAuth 2.0 is really the gold standard for letting third-party apps access user data securely without exposing passwords. API keys are simpler but less granular. JWTs are good for securely passing verified information. All these need strict enforcement, usually right at the gateway. Next, input validation. Absolutely non-negotiable. You have to meticulously sanitize and validate all data coming in from clients. Assume it's potentially malicious. Check data types, lengths, formats, allowed characters. This prevents common attacks like SQL injection, cross-site scripting, XSS, all sorts of nasty stuff. Never trust client input.
Okay, validate everything.
Everything. Transport layer security, TLS SSL, is mandatory. Encrypt all data in transit using HTTPS. Between the client and the API, and ideally between the gateway and your backend services too. Protects against eavesdropping and tampering. Foundational. As we just discussed, rate limiting and throttling are also key security tools. Beyond just performance, they shield you from denial of service attacks, brute force login attempts, and general abuse by capping how much any one client can do. Contains the potential damage.
Right, security aspect too.
Absolutely. Comprehensive monitoring and logging are crucial for detecting problems fast. Tracking API activity lets you spot suspicious patterns, weird traffic spikes, lots of failed logins in real time so you can respond quickly. Logs need to be detailed, secure, and tamper-proof for later analysis if needed. Always follow the least privilege principle. Only grant the absolute minimum permissions necessary for an API consumer to do its job. If an app only needs to read data, don't give it write access. This massively limits the damage if a key or token gets compromised.
Minimize the blast radius.
Yeah, exactly. And finally, the API gateway itself acts as that critical security enforcer. By centralizing policies for authentication, authorization, rate limiting, maybe even basic threat detection like checking for known bad patterns, it becomes your first and often most effective line of defense. It ensures consistent security across all your services and reduces the risk of one service forgetting a crucial check, essential for protecting Innovate Core's valuable data and systems.
That's a really solid security blueprint. The gateway is clearly a powerhouse. Okay, this is already a huge amount to cover, but it feels like the API world is just constantly shifting. New tech, new ideas popping up all the time. What's next? What's on the horizon for APIs? Right, so we've covered their foundational role, designing for scale, interoperability, management. But where is this all heading? What are the really interesting emerging trends shaping the next, say, decade for APIs? What's the cutting edge look like?
Yeah, this is where it gets really exciting, because the API landscape is incredibly dynamic. It's constantly adapting. One of the biggest influences we're seeing now, something that's going to profoundly reshape how APIs are built and used, is how AI and machine learning, ML, are impacting API development.
Ah, AI, of course. How does that apply here?
In several ways. First, AI could help with intelligent API design. Imagine using AI to crunch vast amounts of API usage data, finding patterns, bottlenecks, common developer struggles, and then proactively suggesting improvements to your API contracts. Or even automating parts of generating the API itself could lead to much more intuitive, performant APIs with fewer human design errors.
So AI helping design better APIs.
Potentially, yes. Second, for API discovery and consumption. In large organizations like Innovate Corp with maybe thousands of APIs, finding the right one for a specific job can be tough. ML algorithms could help developers find and understand relevant APIs much faster, maybe recommending the best fit based on the context of their code, slashing integration time.
Okay, smart recommendations.
Then on the operations side, AI could enable predictive scaling, analyzing historical traffic, trends, maybe even external events like upcoming holidays. AI could anticipate future API load spikes and proactively scale resources up or down. Better performance, better cost efficiency, maybe preventing outages before they even happen.
Proactive scaling. Nice.
And enhanced security is a big one for AI. AI could be much better than traditional rules at detecting anomalous behavior in API traffic. Things like requests from weird locations, sudden error spikes from one user, patterns that look like brute force attacks. AI can flag or block this malicious activity much faster and more accurately.
Smarter threat detection.
Definitely. And finally, maybe the most transformative aspect, the rise of AI-powered APIs themselves. APIs that directly expose sophisticated AML models as a service. This lets any developer tap into capabilities like natural language processing, image recognition, sentiment analysis, predictive modeling, without needing to be an AI PhD or build these complex models themselves. It's democratizing AI through APIs, opening up huge innovation potential everywhere.
Wow, that's huge. APIs becoming smarter and being the way we access AI. Okay, another area I keep hearing about is WebAssembly. How does WebAssembly, WASM, fit into the API picture? What's its potential impact?
WebAssembly, or WASM, yeah, it's another truly transformative technology gaining serious momentum. It started as this low-level bytecode format for running high-performance code inside web browsers, but its influence is spreading way beyond the browser now, onto servers, edge devices, everywhere. It's designed as this super efficient, compact, secure target. You can compile various languages like C++, Rust, go into, and it runs really, really fast, close to native speed.
Okay, fast and portable. How does that help APIs?
Profoundly. First, think about edge computing.
Yeah.
WASM lets you run bits of API logic, complex validations, maybe even small microservices right at the network edge, super close to the user. This slashes latency because data doesn't have to travel all the way back to a central server for processing. Imagine Innovate Corp running instant input validation or personalized routing right on a CDN edge server using WASM, much snappier user experience.
Lower latency at the edge. Cool.
Yeah. Second, in the serverless functions world, things like AWS Lambda or Azure functions that are often used for API backends, WASM offers a more efficient runtime. Serverless can sometimes have cold start delays or use more resources than ideal. WASM modules start incredibly fast, use minimal resources, making them perfect for highly performant, event-driven API endpoints.
Leaner serverless. Got it.
Third, and this is great for complex places like Innovate Corp, WASM enables polyglot environments. Developers can write API logic in their favorite high-performance language, maybe Rust for speed, maybe Python for ease of use. They compile it down to a universal WASM module. That same module can then run anywhere, browsers, serverless, IoT devices, with consistent high performance. This could lead to these incredibly lean, super fast, highly portable, and inherently secure API components you can deploy almost anywhere, ensuring consistent behavior and speed across all sorts of infrastructure. Big potential for reducing friction.
That paints a picture of really lean, fast, versatile APIs in the future. Okay, looking even further out, maybe the next 10 years. What are your boldest predictions for the whole API economy? Where's this all going? What will companies like Innovate Corp need to deal with?
Looking ahead, I see several big shifts shaping the API economy. First, we're really heading towards API first, everything. APIs won't just be for internal plumbing. They'll become the primary way software and business capabilities are accessed. Companies will design products thinking about the API first as the main interface.
So the API becomes the product, almost.
In many cases, yes. Second, expect much more hyper-personalization. APIs will get smarter, more granular, tailoring data and experiences to individual users or specific situations in real time, probably fueled by that AI we talked about. Moving beyond generic responses to highly relevant context-aware interactions. Third, increased specialization. While we'll still have broad APIs, we'll see huge growth in niche APIs for specific industries. Think healthcare APIs meeting very specific standards, or finance APIs for complex trading or very specialized functions. Deeper integration within vertical markets.
Okay, niche APIs.
Fourth, and this is a big shift in how things interact. Event-driven architectures, EDA, will become much more dominant. Traditional APIs are mostly request response. The future is increasingly asynchronous event-based. Instead of asking an API, is there an update, systems will subscribe to events like Innovate Corp order placed or inventory updated and react instantly. Crucial for real-time apps, IoT, complex workflows.
From conversations to notifications.
Good way to put it. Fifth, API gateways will evolve into intelligent hubs. They'll do more than just routing and policies. They'll become sophisticated orchestrators, maybe running serverless or WASM logic on the fly, handling complex data transformations, even light business process automation. Smarter gateways. And finally, an even increased focus on API governance and observability. As API landscapes get more complex and strategically vital, the tools and practices for managing them, ensuring compliance, tracking performance, understanding their full business impact, they'll become incredibly sophisticated. Maybe even moving towards proactive, self-healing systems to keep it all manageable and secure for Innovate Corp and everyone else.
That's a mind-bending, but really practical look ahead. APIs weaving even deeper into business. Okay, so for you, our listener, what does this all actually mean? How do we connect this deep dive into API tech back to core business goals? How do we translate this into real strategic impact for organizations like Innovate Corp?
That's exactly where the rubber meets the road. The most effective API strategies, the ones that really deliver, are those tightly aligned with the overall business objectives. It's so important to understand that API success isn't just about, 99.99% uptime or low latency. It's fundamentally about delivering tangible business impact, which means we need the right metrics for evaluating API success. Key performance indicators, KPIs, that go way beyond just the purely technical stuff.
Okay, so what kind of business KPIs should we track?
Well, while the technical KPIs are still important, error rates, latency tell you about health and reliability. You absolutely have to measure business-oriented KPIs too. For instance, API adoption and consumption rates. How many developers are actually using your API? How often? What's the volume? High adoption usually means your API is providing real value. Critically, developer satisfaction, DX, which we talked about, is a huge leading indicator. You can measure it with surveys, feedback, tracking things like time to first call. How fast can a new dev get up and running? Good DX leads to more usage, more integrations, more loyalty, which directly speeds up innovation for Innovate Corp.
Right, happy developers build more stuff.
Exactly. If you're monetizing, then monetization revenue is obviously a direct financial KPI. But even if an API isn't sold directly, its broader business impact is key. Does the API enable new strategic partnerships that open new markets? Does it actually shorten your time to market for new products? Does it demonstrably boost user engagement in your main apps, like those seamless experiences we discussed? Does it lead to real cost savings by automating processes or improving efficiency? Those are the real measures. And crucially, every KPI you choose has to tie directly back to a specific business goal and be communicated in business terms, not just tech speak.
That makes it really clear APIs are a core business concern. But speaking of business terms, for non-technical folks, executives, sales teams, marketing the language of APIs, microservices, gateways can feel pretty alien, maybe even intimidating. How do you effectively communicate the value of APIs to those stakeholders who might not get the tech details?
That's a major challenge for technical leaders, yeah, but it's also a huge opportunity to act as that bridge builder. The absolute key is ditch the technical jargon. Focus entirely on quantifiable business outcomes. So instead of saying, we implemented GraphQL for efficient data fetching, reducing overfetching by 40%, you say, our new customer data API cut customer onboarding time by 30%. That directly boosted our conversion rates and helped us gain 5% more new customers last quarter. See the difference?
Huge difference. Focus on the result.
Always the result. Or, by exposing this API, we landed 3 new strategic partners, opening up completely new revenue streams in markets we couldn't reach before. Use analogies they understand. Talking to marketing. Explain how APIs let them instantly pull personalized customer data into their campaign tools without manual work, boosting campaign ROI. Talking to finance. Focus on how APIs streamline billing or automate reporting, saving X dollars or improving compliance Y%. Quantify benefits whenever you possibly can. Show the numbers. Money saved, new customers, efficiency gains. Highlight the competitive advantage how APIs let you innovate faster, reach new markets, create unique experiences competitors can't easily copy. And don't forget risk reduction. Good API security means better data protection, better compliance, which is crucial for everyone and prevents costly problems for Innovate Corp.
That's a powerful way to frame it, speak their language, show the impact. Okay, finally, to make an API strategy really stick, it sounds like you need more than just good tech and good communication. You need the right kind of culture in the organization. How do you actually foster that, specifically by building a culture of collaboration between developers and management?
This might be the most critical piece for long-term sustainable API success. A truly robust API strategy needs you to genuinely bridge that gap between the technical teams and the business leadership. Too often, devs are just seen as order takers, or business folks don't really grasp the tech possibilities or limitations, create silos, leads to suboptimal results.
So how do you break down those silos?
First step is fostering a shared understanding. Both sides need to get the why behind API initiatives. Why are we building this API? What specific business problem does it solve? What's its strategic importance for Innovate Core's future? Developers need the business context, and business leaders need a high-level grasp of the tech realities. Regular structured discussions, maybe even joint training, can help build this shared language.
Okay, get everyone on the same page.
Exactly. Next, cultivate cross-functional teams. Don't just bring in business stakeholders at the end for sign-off. Involve product owners, sales reps, customer support folks right from the beginning in API design and strategy discussions. Their different perspectives ensure the API actually meets market needs, is practical, provides real value, prevents building technically perfect APIs that nobody uses.
Get diverse input early.
Crucial. Establish clear, consistent feedback loops. Developers need to hear regularly how their APIs are being used, what problems users face, what new opportunities the business sees. And business teams need to understand the technical feasibility, timelines, maybe the technical debt implications of their requests. This ongoing dialogue aligns priorities, lets you adapt the strategy, and builds mutual respect.
Two-way communication.
Absolutely. And finally, empowerment. Give developers the right tools, the autonomy to build high-quality APIs, but always within the context of clear strategic objectives. Trust them to make good technical decisions while guiding them with the business goals. When you have that true collaboration where developers and business leaders co-create and understand each other's worlds, that's when you get APIs that are not just technically sound, but truly impactful for the business. Drives real innovation and growth for Innovate Core and any company that gets it right. #outro.
Wow, what a journey through the API ecosystem. We've really unpacked a lot today. From their fundamental role enabling agile microservices and those seamless user experiences we all appreciate, to the nitty-gritty of designing them for huge scale, thinking about REST versus GraphQL, and ensuring they can actually talk to each other across all sorts of different systems, that whole interoperability piece.
Yeah, covered a lot of ground.
We definitely did. Then we dove into the critical role of API management tools and gateways for keeping everything secure and scalable, and even explored how APIs can become direct revenue drivers through smart monetization, turning tech into business opportunities. And looking ahead, the future trends, AI and machine learning's influence, WebAssembly boosting performance, it's incredible. And tying it all back to aligning API strategy with core business goals using the right KPIs, that really brings it home. So whether you, our listener, are a developer building the next big thing, a technical leader guiding your team, or a product manager shaping what's next, hopefully this knowledge helps you build more effective, resilient, and truly innovative solutions that make a real difference.
And this does raise, I think, an important question for you to take away and think about. As digital transformation just keeps accelerating and APIs get even more deeply woven into everything we do, how will you leverage APIs not just as a technical tool for connecting things, but as a core driver of innovation and competitive advantage in your own specific context? Really consider how the principles we discussed today, from strategic design and solid testing to robust management and building that collaborative culture, might apply directly to the challenges and the opportunities you face every day. How can you use this to unlock new possibilities for your work, for your organization? The insights today are really just a starting point for your own continued learning in this fast-moving space.
That's a fantastic final thought. Thank you so much for joining us on this deep dive. We really hope it provided those aha moments and gave you a shortcut to being well-informed on this absolutely crucial topic. Until next time, keep exploring, keep learning, and keep asking those fascinating questions.